So welcome everyone to this talk about Wikipedia and the lean data diet. And I'm giving this talk on behalf of the Wikimedia Foundation, where I am now a volunteer. The Wikipedia is a very different ecosystem. So volunteers contribute to as engineers, but also, as you probably know, the Wikimedia Foundation has nothing to do with the content of Wikipedia. It's just the nonprofit that handles the infrastructure for Wikipedia, right? That means that it maintains the servers, it administers the funds to pay for data centers and to pay engineers such as myself. I worked there for 6 years in the data pipelines of Wikipedia, building them as a full-time engineer. And I've now moved to be a volunteer because I have a full-time job somewhere else. But my work in data continues, and I wanted to share some of the privacy work that we've been doing at the foundation. And this idea of the lean data diet is a concept that I'm very glad that now has a name, because it's a practice that we were doing at Wikimedia for a long time, but it didn't have like a catchy name that you could communicate it with. And the idea is that you should be very purposeful about the data you gather and make sure that it truly enhances the product that you are trying and the value that you're trying to provide to your customers or your users. In the case of Wikipedia, users, obviously, as it's a free resource. So the good thing about giving a talk about Wikipedia is that everybody knows the product, right? Most people here are probably users of Wikipedia as readers. There's probably people here that contribute also as editors. And the important thing to know is that the Wikimedia Foundation, as I say, administers the infrastructure for Wikipedia, but has nothing to do with the content, right? Like the content for Wikipedia is provided by volunteer editors all over the world, sometimes as many as 100,000 every month, right? And why is this important? Because you may have never thought about it this way, but when you read Wikipedia, you participate on this wider movement that is called the free knowledge movement. And the idea is that the free knowledge principle is that you should be able to create or consume knowledge without any strings attached. And when you read Wikipedia, you're benefiting from this movement, right? You're benefiting as a passive consumer of knowledge. And when you're editing Wikipedia, you're providing content to the movement. So the ideas around privacy in Wikipedia do not stem from this new awareness about privacy that we all have seen how it exists in the world. I think the internet at large was not aware about privacy until probably the last US presidential election. I think that's what brought it to light. But in Wikipedia, the notion of privacy has existed for a long time, as it stems from this idea of free knowledge. So there are two fundamental beliefs around privacy on the free knowledge ecosystem. The first one is that you shouldn't have to provide information to consume or produce knowledge. That means that you should be able to read Wikipedia without a terms of service, without an account, and likewise, you should be able to edit content without having to provide any information. And so everybody knows, everybody can edit Wikipedia, right? So the idea is that the free knowledge guarantees apply to both readers and editors. And how are those guarantees expressed in the ecosystem? So the answer to this question, while this up to now is very philosophical, right? We're talking about concepts of privacy and free knowledge and expression, but how is that concretely expressed in the world of the internet? And the answer is not super exciting. It's the privacy policy of the Wikimedia sites, because for all the Wikipedias in the world, there is about 200. But what is different about this privacy policy is that it is not like the privacy policies that we all had to sign in when we did GDPR, right? And you were getting all those emails about signing up privacy policy. The privacy policy of the Wikimedia sites was created just like the wikis and the content of Wikipedia. It was built the wiki way and was built with the community, with a large set of the community that really care about privacy and the principles around it. And the discussion around the content of the privacy policy was about 150,000 words, which is, to quantify that, is as large as the second volume of the Lord of the Rings, right? So this was the discussion that came to be the policy. So as you can tell, like lots of people all over the world care about it. And that discussion is still public. And if you wanna dig it out, you shall find it. And what are the main things the privacy policy says? So you should be able to read or edit with your own account. You don't need to register. And the Wikimedia Foundation, as the steward of Wikipedia's data, is never going to share it with third parties. And after 90 days, the data will be mostly deleted, aggregated, or de-identified. The main idea is that after 90 days, you really cannot keep what are browsing sessions. We don't want to know what a user was reading after 90 days. We will completely discard that data. We release public data all the time. So it could be that the data becomes to be part of a larger aggregated data set, but it will never be kept in granular records. So the privacy policy has very strong implications of how do we do engineering, right, at the foundation, because the very strong one that is the subtext of what we just talked about, the never selling and sharing your info with third parties, this has the super strong implication that Wikipedia runs on premise, what is called. So it does not run on AWS, it doesn't run on Google Cloud or the Microsoft Cloud. It runs on data centers that the Wikimedia Foundation administers that have machines and DC ops engineers that work for the foundation. And there's a public Puppet repo on GitHub where you can look all the software that is deployed. And perhaps this is less important for the privacy themes that we are talking about in this meetup, but you can see how this impacts tremendously how the software is built, how it's released, and how it is conceived, right? The whole software cycle. For the conversation here, what matters the most is that we try to compute metrics in a privacy conscious manner, and we aggregate and release publicly and delete a lot of data. So there are three things that I'm gonna talk about that are concrete measures that stems from the privacy policy, the practices, and the philosophy that are more on the engineering realm. One is deleting data, sanitizing data, which is called pseudo-anonymization, which is like a risky practice. Probably many people here are aware of that. And the most complicated of them all, which is building a privacy culture. So deleting data at scale seems much more easy than it really is. Because when you are deleting data in large volumes, your data is going to be probably in different systems. It may be in HDFS, but it's also in Cassandra. It could also be on like analytics data store as Druid. So deleting data, and there's quite a lot written about this topic of why deleting data at a scale is something that requires like thinking. So what type of data are we talking about here? Mostly the data that we have in large quantities in Wikipedia is data from readers. So data would look like this, like a regular web request, a project, a Spanish Wikipedia, an IP address, a user agent, and a page, in this case, the COVID-19. And there is also some smaller part for what we call behavioral data, which is akin to Google Analytics data, like some editor with some IP address that has edited like 4,000 times, click on this UI feature that is called Minerva, right? So these two types of data that refer to readers and behavioral, like usage of the UI. So the problem with deleting data when you function at a scale is like the volumes of data will be very large, right? Like Wikipedia at peak can get as high as 200,000 requests per second. The graphs for traffic are all public, so you can actually see it. And this is the graph for this year. You can see this is from April, more or less, to August. And you can see some of the highest peaks we had in traffic were due to COVID. And you can see how these are requests per minute, but the peaks that you see here that are happening in May is about what I listed there. So about 200,000 requests per second. For behavioral data, which is like clicking on buttons and uses of features, the volume is much smaller, and it's about 2,000 events per second. So when you delete data like this, you have to be very sure of what is happening, right? Because data deletion mistakes are hard to fix. So pro tip, if you use Hadoop, you can enable trash, works similar to your trash on the desktop. So any deletion will go to the temporary folder that is the trash, and it will live there for some time. That's something to do for safety. But I want to share like a quick tip that is been very useful for us when it comes to data deletion. And I've tried on this talk to simplify the do nots with like X's and the do's with like check marks, like green check marks. So for do nots, like if you have any scripts that delete data, like the absence of default arguments should not trigger any actions that you will later regret, right? So if you have an argument that is tables to delete and it's not present, it should not delete all tables, but it rather should have no action, right? And if you have an argument that is execute and it's not present, it should fall back to the dry run, right? And these are probably pretty obvious to anyone that's worked with data at a large volume before. But something that we've done that has been working really well for us to avoid like clerical mistakes is that when we call our deletion scripts that have like a set of arguments, right? This would be a script that you call for a database call events, table, many clicks, the wiki, English Wikipedia, delete all the data that is older than 90 days, and skip Hadoop trash because this data is really large and I don't want it to occupy space on HDFS. So what we've done is that in order for you to schedule this in Puppet or systemd or any scheduling system, is that first you have to execute this script on dry run mode. And the dry run is going to give you a checksum with all the arguments that you have. And after, in order to schedule the deletion job, you need to add that checksum. That way, if when scheduling the deletion, you make a mistake, and instead of saying older than 90, you say older than 9, nothing will happen because the arguments do not match the checksum, and then it will be an op. The deletion will not get executed. And this is like very simple solution, but on my experience as an engineer, when you do like simple solutions, very low tech, they are alive for a long time, right? They last a long time. And deletion is hard, but probably it's hard for volume and engineering reasons, but sanitizing data, what we call pseudo-anonymization, is hard for different reasons, right? Like pseudo-anonymization entitles a risk, as probably people know here, like anonymization, it really doesn't give you any guarantees, unlike other techniques like differential privacy. And sanitizing data always carries a notion of risk. But what we always try to do is to keep pieces of data that are not identifying of a user or a browsing session. And this is how we do it. And before that, I'm going to describe a little bit what is like the data pipeline, so you can see at what point of the data pipeline the sanitization is happening. It's pretty standard. So the clients will send data to Wikipedia because most of the content that you see is cache. And the content will be served via Varnish, which is an HTTP cache. In this case, a petition comes in, Varnish communicates that petition to Kafka, and a processor pulls it from Kafka into HDFS. And from there, what we do for behavioral data is we consume from HDFS in two streams. One of the streams will be deleted after 90 days, the data entirely, and the other stream is sanitized upon ingestion using an allow list. And all these allow lists that we use are public. And why do you want an allow list? So if the data that you have unsanitized looks like this, and you have an IP address, a user agent, a project, and an action that happened, if you have a do not allow list, you will end up with nulls on the IP and the user agent because you obviously don't want to retain those long-term due to PII, right? But if you add like a third item, like an additional item, sorry, to this list, if you have a do not allow list, you will end up retaining that value when you don't want to retain it. So however, if you have an allow list, then you retain what you're interested on. And when you have like a new field, by default, it will always be non-retained. And obviously this has to be well applied because you want your allow list to be as large as possible to make sure like the data that remains is not identifying, and to truly quantify that, you will need to run an identification algorithm, right? So other techniques that we use is bucketizing, like say from an IP, you can go to like a granular geolocation from this IP to Spain. From a user agent, you can go to the OS, for example. And for identifiers, you could have a hash that hashes that cookie ID with a salt that gets replaced, for example, say daily. So that way you could string together the records of one day, but you cannot really join those records with the records of the next day. And of the things that I'm going to talk about here, this is definitely the hardest, which is building a privacy culture. And I was recently at a privacy conference where we had friends, how do you say, like a small groups that we talk about this, and this was really hard to do. And there were people there from Google, from Facebook, from large organizations, small, and this is probably the hardest because unless privacy is understood as a collective responsibility, ends up being the responsibility of some individuals, right, that may have privacy in the title. So the main thing to convey here is that privacy is not a responsibility of one team, right? But rather like if the organization has a commitment to privacy, privacy is a shared responsibility, the same way that performance is a shared responsibility. It's not the responsibility of the front-end team, it's the responsibility of all engineering teams. And just like performance, all processes should take into account privacy from the beginning, right? You don't want to prematurely optimize, but it's something that you want to think about from the beginning. So I want to share here a practical example of how we compute metrics at Wikipedia in a privacy conscious manner. And I choose as an example the daily active users or monthly active users, which I think is a metric that anywhere else that you have a website, you probably have computed, right? So this metric, normally, how is it computed? If you go, for example, to Amazon, right, you will see that you have a session ID, and every device has a different session ID. It could be a device on an account if you have to be logged in. In the case of Wikipedia, it will always be devices because you don't log in. And in order to figure out how many unique devices you have on one day, since you have assigned a unique token to every device, and it's a cookie that is going to expire on a day or on 30 days, you just count the number of distinct unique tokens that you have on your database for that day. And that will tell you the unique devices for that day, precisely. This is a very standard technique, how it's done in most places, but it has the disadvantage that when you do that, you are adding an identifier to every request, and then it's very easy to tell which is the browsing session of a user, which is what we don't want. In the case of Amazon, Amazon is very interested in seeing which are the items that you browse before this one in order to offer you a recommendation, right? That data is going to be fed into a recommendation algorithm. In the case of Wikipedia, we don't want to have that information because if our government asks us for our records, we want to say, we don't know. We just don't know the article that this person that was looking at article B was looking before. We just cannot tell. So how we compute the daily active users is shying away from using unique identifiers, because we want to make sure that should a hostile party request the data, we don't want to have more data than the default to surrender. And this is explained on a longer blog post that I have linked there in case people are interested. So we call this the last access method. So if you go now to Wikipedia, you would see that you have a cookie that is last access, that it only has the date and that you access Wikipedia last. Like say, for example, this person just opened the computer and the last time they accessed Wikipedia was the 1st of September. So they will go there and they will see that they have a cookie that says 1st of September. They haven't made a request yet. So when they go to Wikipedia because they want to look at an article today that says the 15th of October, they send that cookie that says 1st of September. So we get the request and we write it on our logs. So we write the date of today was the 15th of October, an IP address, somebody look at the page Titanic, and the last access cookie that they sent us said like 0901. So this is September. So because of the way the internet works, we reset that cookie again and we send it back. So now the cookie has been changed to the 15th of October. So this person has this new cookie, and they do a subsequent request to Wikipedia. They look at a second article. That request comes in, we again write it on the logs, and this is how it looks. It looks just like the first one, only that the last access date has changed. So how can I compute the number of unique devices using this technique? So what I do is that I look on my database where I've written all these requests, all the requests that have a last access date that is smaller than the day of today. And that will tell me which were the number of unique devices that hit the site today. And if you notice, this method is no less precise than it would be with tokens, but it definitely, and I'm going to go back to the other slide, it doesn't add one piece of additional information. You can say, okay, but I can tell this person is the same one looking at Titanic and the page Everest if I just create a signature that includes the IP. And that's true. You could do it because its IP hasn't changed. But if this person was moving on a mobile device and had a number of IPs, it's not that easy to string these two records together anymore, right? You don't have that piece of super easy identifier that allows you to string the browsing session. So the only record that I need to compute the unique devices is the first one. The second one, I log it just as a request, but I would no longer need it for the unique device calculation. So to sum up here a little bit for Lean Data Diet, what are, as you can tell from everything that I talk about, there is some pros and some cons, right? Like the cons are obvious, like building a privacy culture, it takes time. And also computing metrics in privacy conscious ways is actually more work. It's a lot more engineering work computing what I described with last access tokens than using like session tokens, right? There's something that you have to think about and that you have to implement rather than use like a common case implementation. There is extra work when you don't use third-party providers, but you could still use third-party providers and compute metrics in privacy conscious manners. Probably the hardest part is to create a culture in which the people that work with data, the data analysts and the data scientists, also buy into this idea of privacy, right? Because it requires like a shift of mindset of how do you think about privacy. Now, definitely there is a lot of pros. It's very easy to make data public. We release data like every hour, basically. The page views of Wikipedia for all projects are released every hour. There is also data set releases monthly. And it's a lot easier to do that if you have practices that remove identifying data from your data set. There's a lot less work related to data requests in many instances, and you can look that on transparency, wikimedia.com. We don't have the data at all that is being requested. And also the most important thing is that you can offer privacy as a feature of your product. In some cases, it will be apparent. And in the case of Wikipedia, it's probably like something like not an apparent feature, but it's something that is under the whole product offering, without which the product will not be possible. And this is my last slide and the thought that I want to leave everybody with, that privacy is itself a feature, right? It's not something that we do, but it's part of our product offering. And this is it. So
wonderful.
Ready for
Thank
questions.
you. That's great. We'll get right into the questions. We've got a really great list so far. And if other folks want to drop any into the chat or the QA, please feel free. First up from Harry, with the sanitized list, do you still have to handle deleting user data?
With the sanitized list, do we still have to handle deleting user data? Yes, a lot of it, like anything that would be like granular data, like records like user agents, for example, or like any identifier that will be linked to your device, because there would be cookies that are also sent. So loads of user data is being deleted. And that sanitized list is public for all the data that we gather. So you can see actually what user data is deleted.
Great. And just a quick drill down, just to make sure I got the whole question. If a user requests their data to be deleted, how do you find that user's data?
In most instances, we don't have any data for any user, which I know sounds very, very radical, but that's normally the answers because we cannot identify users in the data, and the data is most of the time no longer there after 90 days.
Great.
So let me make one clarification.
Please.
So in the Wikipedia ecosystem, there's something particular because there's the readers data, which is most of the data that I just talked about here. And after there's edit data. And the edit data records for Wikipedia are public, similar to if you have an open source project, you use the software and the git commit log is also public, how the software came to be to that stage. So for Wikipedia, the content is public in XML files, you can download them. And also the edits of how the content came to be that way are also public. The editors' names are not, however, identified with an email address or similar, right? You could be like editor red25, right? So that data is always public. The user data we're talking about here is data from readers, and that data, most of it is deleted after 90 days.
Great, thank you for that clarification. That was very helpful. Can you share any mistakes you made when first setting up the data minimization practices and how you learned from them?
Yes, so the anonymization, the pseudo-anonymization, let's say it that way, because it's never true anonymization. So there was many mistakes that were made at the beginning. For example, the idea that you will have like an allow list versus a do not allow list. So it's always easier to have the allow list. That was a practice that we discovered after having made some mistakes. And also when we talk about hashing and salt rotations, you have to be very precise how long your salt is going to live and when are you going to change it, right? Because you can have a salt that lives from 1 day, allows you to identify records within the day or for 30 days, and the risks are different in those two scenarios. So true, it's easy when you start doing like pseudo-anonymization, it's like a hard balance. We try to err always on the side of deleting more than keeping more.
Perfect, thank you. Martin's got a question for you. Do you not consider the IP address, or do you not consider the IP address to be sensitive in the same way as a UUID?
So IP addresses for readers are always deleted, yes. But IP addresses in a world in which people mostly use mobile devices are not they are not so telling us of a user as in the world where desktops were your primary source of browsing the internet. Like think for Wikipedia, there are projects like, for example, Indonesian Wikipedia, that 90% of it is mobile devices that are changing their IP address continuously, or they have big umbrella IPs under which literally there is millions of people. So it depends. However, if you are from like a computer that is a desktop computer on a library, yes, your IP is identifying, probably hyper-identifying that location. But that on the bulk of the user base, you cannot make that claim, if that makes sense. And I can describe that in more detail.
Perfect. Okay, Martin, drop a chat if you've got a follow-up on that. Let's head to another question. How are your sanitization practices informed by literature on re-identification attacks?
So this is a question that is always ongoing. So we try to do two things, like try to run identification scenarios ourselves, like how is it to reconstruct a browsing session from this data, and guard against like the pieces of data that make that identifying. But it's something that normally we enlist expertise. We collaborate with like a number of organizations in the world, and we enlist outside expertise to help us with questions such as those. But no, the true answer to that is like, as people probably know here, it's like anonymization doesn't give you a guarantee. It's not like differential privacy techniques where you can express the guarantee of privacy pretty clearly in mathematical terms.
Perfect. We've got a lot of questions in, but we'll only take a few more. So Raj asks, are you considering to use differential privacy technologies to overcome the pseudo-anonymization challenges?
So yes, that for like, this is clearly the future. So the volunteer project that I'm working on with Wikipedia now is me and a group of people working on it, not just by myself, is exactly this. It's like, how can we move from pseudo-anonymization, especially for data releases is important, right? Because we release loads of data publicly, and there's some data that is private enough that we cannot release it, like page views, like article, page views per country, per project, right? Like that, you can see how that data will be very sensitive. So in order to be able to release it publicly for the world, we will need a differentially private solution. Yeah, it's not trivial, but it's like a super compelling problem.
That's great. Wonderful. Last question before we wrap up, and thank you for your time. The last question is, how do you balance privacy with being able to detect and address abuse between users?
So there's instances, normally the instances of harassment that happen in Wikipedia happen among editors. There's what we call like editor wars in what are very hot topics. And this is also very particular. All that data is always public for what I explained before. That data about edits is released normally every month publicly. So all the data around like challenges with editions of articles and editors get it into what we call editors' wars, and sometimes open harassment of like minority editors, all that normally is public. Unlike the reader records of what articles you're reading, that is normally private data. This has been public since the beginning of Wikipedia. Like if you want to start a Wikipedia right now, you have 20 years of like dumps of Wikipedia and you can get started. You have like a head start.